Periodicity. In periodicity, you will learn about atomic or ionic radii, first ionization energy, electronegativity, and acid-base character for elements in period 3. We cannot measure the exact size or radius of an atom. The size or radius of an atom is measured by measuring the distance between the nuclei of two atoms. For trend in atomic or ionic radii, you will learn on how the atomic radii of the elements change across the period, down the group, isoelectronic series, comparison between atomic and its corresponding ionic radii, and also transition elements. Generally, across the period, the atomic radius of the elements decreases. As for down the group, the atomic radius of the elements increases. Isoelectronic series defined as groups of atoms and ions which have the same electronic configuration. Generally, the size of the isoelectronic series decreases as the proton number increases. As for atomic versus the ionic radii, the cation is smaller than its neutral atom, and the anion is larger than its neutral atom. First ionization energy is defined as the minimum energy required to remove 1 mole of electron from 1 mole of gaseous atom. Generally, across the period, ionization energy increases, and down the group, ionization energy decreases. Electronegativity is the relative tendency of an atom to attract bonding electrons closer to itself in a chemical bond. Generally, across the period, electronegativity increases. Trend in atomic radius. There are two factors affecting the atomic radii. The first factor is the effective nuclear charge, or ZEF, and the second factor is the shielding effect. The effective nuclear charge is the residual net charge felt by the valence electrons, where ZEF is equal to Z minus S. Z is the proton number, and S is the number of inner shell electrons. As proton number increases, the effective nuclear charge also increases. The attraction between the nucleus and the outermost electron also increases, where the valence electrons are pulled closer to the nucleus, so the atomic radii decreases. As for the shielding effect, number of shells filled by electron n increases. The shielding effect also increases. Weaker attraction between the nucleus and the valence electron, so the atomic radii increases. Down the group, as the number of shells filled by electrons increases, the shielding effect also increases. The nuclear attraction also increases, in which the valence electrons will be less attracted to the nucleus, hence the size of atoms increases. Across the period, as the proton number increases, the effective nuclear charge also increases. The nuclear attraction also increases, whereby the valence electrons will be attracted closer to the nucleus, hence the size of the atoms decreases. Transition elements. These are the elements from first row of transition elements. As the proton number increases, the additional electrons are filled in the inner 3D shells. Thereby, the number of shielding electrons increases, but the outermost shell 4s remains constant. Thus, the valence electrons experience a comparable nuclear attraction. Therefore, going across the transition series, the atomic radii remain almost constant.